Hi everyone. In this video, we are going to learn about metal displacement reactions. In a metal displacement reaction, a more reactive metal will take the place of a less reactive metal in its salt solution. For example, when an iron nail is put inside a test tube containing copper 2 sulfate solution, a displacement reaction will take place. This is because iron is more reactive than copper. During the reaction, the blue solution loses its color and the iron metal is seen to turn brown as the displaced copper becomes deposited on it. Now, this is the chemical equation for the above mentioned displacement reaction. Iron plus copper sulfate gives iron sulfate plus copper. How do we know which metal would displace any other metal? For this, we need to go back to the reactivity series. The reactivity series will allow us to predict how metals react. In the reactivity series, the elements are arranged as potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, tin, lead, hydrogen, copper, silver, and gold. The elements are arranged from the most reactive to the least reactive. It is important to learn the reactivity series so as to answer a number of questions in the examinations. Let us look at another example of a displacement reaction. This is the reaction between magnesium and copper 2 sulfate solution. Since magnesium is more reactive than copper, the copper metal is displaced. You can see that the blue color of the copper 2 sulfate fades as it is used up and the solution becomes colorless. Magnesium sulfate solution is colorless. We would also see copper metal forming. The copper metal is the brown deposit at the bottom. What happens if a less reactive metal is added to a metal salt solution? There will be no reaction. Nothing will happen. For example, if an iron nail is placed inside magnesium sulfate solution, there will be no change. This is because iron is less reactive than magnesium and so cannot displace it. The earlier two examples involved displacement from metal salt solution. Now let us look at an example for a displacement reaction involving metal oxides. The thermite reaction is a good example of this. It is used to produce white hot molten iron, which is used in remote locations for welding railway lines. Heat is needed to start the reaction, but a large amount of heat is also released, which helps to melt the iron. The equation for the reaction is aluminium plus iron 3 oxide gives iron plus aluminium oxide. Because aluminium is more reactive than iron, it displaces iron from iron 3 oxide. Now this is a useful displacement reaction. Now let us look at some questions on displacement reaction. One way of establishing a reactivity series is by displacement reactions. A series of experiments was carried out using the metals lead, magnesium, zinc, and silver. Each metal was added in turn to aqueous solutions of the metal nitrates. The order of the reactivity was found to be as given here. Complete the table. So you need to put a tick if there is a reaction and an X if there is no reaction. Okay, now these are the answers. The first metal is lead. Lead is less reactive than both magnesium and zinc. Hence, there is no reaction. Lead is more reactive than silver and hence it can displace silver, so there is a reaction. Magnesium is more reactive than both zinc and silver, so there is a reaction. So we put a tick in both the boxes. Zinc is less reactive than magnesium, so no reaction. Zinc is more reactive than silver, so there is a reaction. Silver is less reactive than both magnesium and zinc, hence no reaction. Next question. Displacement reactions are redox reactions. On the following equation, draw a ring around the reducing agent and an arrow to show the change, which is oxidation. Now, in this equation, lead ion has become lead atom. There is a decrease in oxidation state, which is a reduction. Lead ion has undergone reduction. So zinc is the reducing agent. Okay, so the answer for reducing agent is zinc. The arrow that shows oxidation will be from zinc to zinc ion. Okay, the oxidation state has increased. So it is oxidation. Or we can also use the other definition where oxidation is the loss of electrons. The zinc atom has lost electrons to form positive zinc ions. So zinc has undergone oxidation. Hope you found this video useful. Thank you.